Hi students, today we will solve the question number 7 from chapter number 3. This is physics class 9. The question states that a cyclist weighing 55 kg rides a bicycle of mass 5 kg. He starts from rest and applies a force of 90 Newton for 8 seconds. Then he continues a constant speed for another 8 seconds. Calculate the total distance traveled by the cyclist. First of all, we write the syllabus, we write the data here. That is the mass m, and here we represent m, the total mass of the rider, which is 55 kg, and the mass of the bicycle, which is 5 kg. When we add these two masses, we get the total mass as 60 kg. Similarly, he starts from rest. Rest means his initial velocity, that is vi, that is equal to 0, and he applies a force of 90 Newton. Force we represent force by capital F, and F is equal to 90 and Newton for 8 seconds. So this is the time, small t, that is equal to 8 seconds. First of all, we calculate the acceleration, that whenever a force of 90 Newton acts on a body of mass 60 kg, the how much acceleration is produced in this in the body, that is A can be calculated by dividing the force with mass, that is A is equal to F over m. Force is 90 and Newton, and mass is 60 kg. So when we divide, then we get the acceleration as, and Newton per kg gives meter per second square. So to calculate the distance which it covered during this time when he applied the force of 90 Newton in 8 seconds, we will use the second equation of motion, which is S is equal to VIT plus 1 over 2 AT square. Now we put the values here. Vi, initially the body was at rest, so Vi is 0, and the value of t is here 8 seconds plus 1 over 2, and acceleration we have just calculated, it was 1.5, and the time is 8. And since time is squared, so we will square 8. So 0 multiplied by 8 will give us 0, and plus 1 over 2 multiply by 1.8, and the square of the 8, which is 64. When we divide 64 by 2, then we get 32, and multiplying 32 with 1.5, we get 15 twos are 30, and 15 threes are 45, and plus 3 48. It means that the body covers a distance of 48 meter during the first 8 seconds. Then the body moves with a constant speed. If I draw a graph here, this is speed time graph, speed on the y-axis and time of on the x-axis. Firstly, the body was moving with an increasing velocity, that is with uniform acceleration. The graph is like this. Then after 8 seconds, it moved with a constant speed for next 8 seconds. So it means that First of all, we have to find this constant speed with which it went on moving. Since here it was initially at rest, this was Vi, and here it will be Vf. So first of all, we calculate the final velocity after 8 seconds when the force was applied, and the formula for the final velocity is Vf is equal to Vi plus At. Here Vi is equal to 0 and plus acceleration was 1.5, and the time for how long the force had been acting, it was 8 seconds. When we multiply these, we get as 12 meter per second. This is the velocity with which the body kept on moving for next 8 seconds. So during this time, the distance which is covered by the body can be calculated by S is equal to Vt, because here the speed was constant or the uniform, and we can write as Vf also, because here we have written that velocity as Vf. So Vf is 12, and the time is again it is 8 seconds, and 12 eights are 96. So he covered the distance of 96 meter in next 8 seconds. If I represent this distance by S2 and this distance was represented by S1, then the total distance S can be calculated as adding S1 and S2. So we write here S1 is 48 and S2 is 96. Then when we add them, then this they give 144. Since it is distance, its units are SI units are meter. So the body totally in 8 plus 8, that is 16 meter, it covers a total distance of 144 meter, out of which he was accelerating in first 8 seconds, and next 8 seconds it was moving with uniform speed. Thank you very much for watching this video. 1.5 meter per second square.